You're welcome back. This is Mr. Hassan's Maths channel, and I'm now answering question number 13 from the C12 IAL Edexcel paper from January 2020. This question is about trig, equations, and identities, and this is a P2 topic now. It's a P2 topic. So in this question here, we must show detailed reasoning. Solutions relying on calculator technology are not acceptable. Bold type, meaning you can't just use your calculator function on equations and write down the answers and expect to get any marks. You have to show your steps properly, that you know how to solve these trig equations. Now here we have a trig equation which is one where we have this sine of an angle equals a half. So finding the angles is pretty straightforward, but the problem here is the fact that they're giving us this kind of compound type of angle, multiples and things added to theta. All right, so they're asking us to find the angles, all the angles between 0 and pi radians. This is now in radian mode we have to be because the limits are given in terms of radians. We have to find the exact solution, probably means in terms of pi, for this equation here. So the first thing you do when you see a question like this is whatever the limits that is given, what's in here and what's over there must be the same. So the limits must be modified accordingly. So what I'm going to do, we start off with 0 is less than theta is less than or equal to pi. What I'm going to do is I'm going to first multiply every part of this inequality by 2. That becomes 2 pi is less than or equal to, 2 theta is less than or equal to 2 pi, which is greater than or equal to 0. So 2 theta is greater than 0 and less than or equal to 2 pi. And then I'm going to add 3 pi over 8 to each of these parts. So I have 0 plus 3 pi over 8, that's going to be 3 pi over 8. Of course, this is 2 theta plus 3 pi over 8, which is what we wanted it to look like in the first place, and less than or equal to, now we're going to have 2 pi plus 3 pi over 8. Now 2 pi plus 3 pi over 8, I'm going to deal with things in terms of fractions because we want to give answers in exact form, so I'm going to deal with things in the exact form like we're using fractions. Now 2 pi is the same as something over 8, it's 16 pi over 8, plus 3 pi over 8, that's 19 pi over 8. So that's the limit of our solutions. We have to grab all the angles between these values, and then in the end I have to rearrange for theta to find the value in terms of theta. Okay, so or a theta as a subject in terms of pi. Now, first, what we're going to do now is we're going to just use our calculator to find inverse sine of a half. So we've got 2 theta plus 3 pi over 8 is equal to inverse sine of a half. Now I must make sure that the angles are in radians. So my calculator must be in radian mode. Okay, right now the calculator is in degree mode. So I'm going to put it in radian mode using this. So now it's in radian mode. Now I'm going to find inverse sine of a half, which I know is pi over 6, actually, just in case. Right, inverse sine of a half is pi over 6 because it's the same as 30 degrees. Pi over 6, okay? So I've got 2 theta plus 3 pi over 8 equals pi over 6. Now, I've got to make sure my angles are within the range. Now, pi over 6 compared to 3 pi over 8. Let me just write 3 pi over 8 in terms of a number that 8 and 6 both go into. 24. 8, 16, 24. That's 24. 3 times 8 is 24. 3 times 3 is 9. That's 9 pi over 8. And this is 2 theta plus 3 pi over 8 less than or equal to. This is also, I'll express it in terms of over 28. So that's going to be times 3 19s are 57. Okay, so I have to make sure that my answers are within this range. Now, if I look at pi over 6 is actually less than this because pi over 6 is over 24, 4 over 24 pi. 4 pi over 24. So this is actually not an angle in my range. But I'm going to write it down and still use it to find other angles. Now, there are other angles which share the same sine ratio of a half, not just pi over 6. There are other angles, infinite number of angles. I've got to find all the angles, okay, which lie within this range, okay, and then I can find what theta is. Now, how do I find those other angles when the calculator only gives me this solution? All right, this is where we have to use the property of the sine curve. So this is why I'm going to go off on a tangent a little bit. Well, not tangent sine, but I'm going to go off on I'm going to explain a bit further for those students who are having a problem with trigonometry and how to find those other angles. Something that's very important for us to know how to do. Okay, so now, how do we use trigonometry to find the other angles? Well, there's different methods you can use. I like to use the symmetry of the curve. Okay, so I'll show you how they relate to each other. So the first angle is always found by the calculator. That's called the principal solution. Okay, that's the principal solution. When you press inverse sine of that ratio, we got pi over 6, that's the first answer. Okay, sometimes it comes out as a negative angle. Perfectly fine. That's the first angle that the calculator gives us. Now for the sine curve, this is for sine. For the sine curve, the second angle is always given by 180 minus the calculator answer. If it's in radians, of course, we'll use pi, like in this case. So pi minus the calculator answer gives us the other angle. Why is that? Well, if we look at the sine curve, we should be able to see why. This is the sine curve between 0 to 360, or 0 to 2 pi. Okay, now the calculator gave us this answer here, which is called the principal solution. All right, there's another angle over here which shares the same sine ratio as the angle. And because of the symmetry of the curve, it's that angle taken away from pi. That angle taken away from pi. So this is pi over 6 less than pi. This is pi over 6 more than 0. This is pi over 6 less than pi. So that's why we're doing pi minus pi over 6. So the second angle is given by pi minus pi over 6, which is 6 pi over 6 minus pi over 6, which is 5 pi over 6. So this angle is one of the angles that we're going to use. Why? Because 5 pi over 6, if you compare it, if you multiply by 4, that's going to give you 20 pi over 24, which is in our range. So that's an angle in our range. That angle is not in our range. Okay? So that's the other solution. Now, from those two main solutions, we should realize once we got these two solutions, the calculator answer and 180 minus the calculator answer, or pi minus the calculator answer, we should realize the sine curve just repeats the same pattern every 360 degrees. So there's another angle which is 360 more than this angle, which is basically going to be 2 pi over 6 plus 2 pi. Okay, so we're going to have pi over 6 plus 2 pi. That's going to be the next angle along, all right, which is going to be pi over 6 plus 12 pi over 6. That's 13 pi over 6. 13 pi over 6, that's the angle over there. Is that in our range? Multiply by 3, multiply by 4. 4 times 13 is 52. Goes up to 57 pi. Yes, that's in our range. That's another angle in our range. Then there's another angle over here, which is 2 pi more than this angle. So it's 2 pi more than 5 pi over 6. Okay, so if you do 5 pi over 6, if you do 5 pi over 6 plus 2 pi, that's going to be basically 5 pi over 6 plus 12 pi over 6, which is 17 pi over 6. And 17 pi over 6, if I multiply that by 4, 4 times 17, 40 plus 28, 60, that's out of our range. So the only two angles in our range are 5 pi over 6 and 13 pi over 6, which are these two angles over here. These are outside of our range. The one the calculator gave us was outside of our range, but we don't reject it. We use it to find angles in the range. So I had to do pi minus that, gave me this angle in the range. I had to add 2 pi to this original rejected angle that gave me, okay, 13 pi over 6, which is in our range. If I try to find other angles, they're going to be outside of the range. If I add 2 pi to this, outside of the range. Of course, the ones on this side, which are 2 pi less than these, they're outside of our range. We only have these positive angles. Okay, how does this relate to some of you are talking about quadrants and sir, you've learned how to do it by quadrants and maybe you don't understand what I'm doing here. I'll relate it to quadrants for those students as well. The calculator gave us this answer. Inverse sine of a half gave us this answer, which was pi over 6 or 30 degrees. Now, the sine curve has the ratios that give positive ratios for sine are, the angles which give a positive ratio for sine are angles which are between 0 and 180 degrees. So 0, 90, which is pi over 2, up to 5 pi, those will give you positive ratios for sine. The angles which are between pi and 2 pi Okay, the angles between pi and 2 pi will give us negative values. Okay, so this ASTC, this is where all of the ratios are positive. Here only the sine is positive, here only the tan is positive, here only the cosine is positive. So the other place where the sine will give us a positive answer is going to be over here. Okay, so that's going to be this angle, which is pi minus the associated acute angle, which is 5 pi over 6. And that was our first angle. Then the angles repeat every 360 degrees after that, which is 2 pi. Okay, then the angles repeat every 360 degrees. So 360 degrees more than this, or 2 pi more than this, is going to be like the angle going all the way around like this, which is the angle that we found, which was pi over 6 plus 2 pi, which is 13 pi over 6. So 5 pi over 6 was this angle here. That was the first angle. And then the other angle we found was 2 pi more than this. Now, if we went 2 pi more than that, that's outside of the range. Okay, so how do we get this ASTC? We get it from the curve. Here, all of them are positive. If you look at the cosine curve, it's positive here. If you look at the tan curve, it's positive here. AS, only the sine curve is positive because after 90 degrees, okay, basically the tan curve goes down here, right? And the cosine curve goes down here. Only the sine is positive, and so on. So we get this ASTC from the sine curve. And these associated acute angles and these symmetries are all kind of linked together. All right? So I personally prefer to do calculator to give me the first angle. Whether it's in the range or not, we still use it to find the other main angle, which is 180 minus that angle. And then from these two angles, we add and subtract 360. So once we've got these two angles, I have angle 1 and 2, I add to them 360, and I take away from them 360. Okay, add 360s and take away 360s, and keep doing that until I'm outside of the range. So that's how we deal with the sine curve. So now I'm going to get rid of all of this stuff here, and I'm going to get rid of all of this stuff here, and I'm going to continue answering the question. Okay, so we have here, let's just get rid of that. Okay, so we have the two main solutions that we found, which were 5 pi over 6 and 13 pi over 6. So I've got here, let me just make a little line to separate this part. So I have 2 theta plus 3 pi over 8 is equal to 5 pi over 6 and 13 pi over 6. These aren't our final answers. The final answer is going to be what theta is, not what 2 theta plus 3 pi over 8 is. So now I have to rearrange these. So for both these angles, to get theta, I have to basically add to them 3 pi over 8. So I've got 5 pi over 6 plus 3 pi over 8, okay, and divided by 2. And same thing here, I've got, which is the same as multiplying by a half, so I can just write it like that, probably better. Say a half times all of this. Okay, and a half times, you're going to have 13 pi over 6 minus 3 pi over 8, and that will give you my two answers. So 5 pi over 6, that's going to be over 24. So you have a half times, that's times 4, that's 20 pi over 24, plus multiply by 3. I've got to subtract, not add, subtract. What am I doing? Subtract, I have to subtract. I did it on the other one, and this one I did. Take away, sorry. So 20 pi over 24, take away, multiply by 3, that's 9 pi over 24. And this is a half times over 24 multiplied by 4. 4 13s are 52. 52 pi over 24 minus, multiplied by 3, that's 9 pi over 8, over 24, sorry. 9 pi over 24. So now we'll have theta is equal to 20 minus 9 is 11. So that's 11 pi over 48. 11 pi over 48, because 2 times that is 48. And that's a half. 52 minus 9 is 43 pi divided by, again, 48. 2 times 24, 48. And those are the two solutions which are in terms of pi, in exact form, within our range between 0 and pi, and the exact values, okay, because they're in terms of pi. So there's the answer for part 1 of question number 13. Okay, now I'm going to move on to part 2. It says solve for x between 0 and this time 360 degrees. So now I have to take my calculator and I have to change it into degree mode. The equation 5 sine x equals 4 tan x, giving you answers where appropriate to one decimal place. Now here I have two different trig ratios, and I have to try to solve this. Either I can make them into one trig ratio, or I can put them in a form where I can write my answers as one trig ratio so I can then solve. Now, right now, there's not much we can really do apart from use the identity that the tangent of an angle is equal to the sine of that same angle over the cosine of that same angle. So the tan of x can be rewritten as this is 4 times the sine of x divided by the cosine of x. Okay, so I haven't divided by cosine x, I have just changed tan x into sine x over cosine x. Now, if I want to get rid of the fraction here, if I multiply both sides by cosine x, okay, this becomes 5 times sine x times cosine x equals 4 times sine x. Okay, now, some people might say, oh, let's divide by sine x. That will get rid of this common factor, both sides. We'll get rid of it, okay? And we're left with 5 cosine x equals 4. But that will make us lose a solution. Just like if I had, for example, 3x squared equals x. If I divide by x, I'm going to lose one solution. I'll get 3x equals 1, x equals a third. But that, actually, there's another solution. To solve this, we should have said 3x squared minus x equals 0. Take x as common. Then you have 3x minus 1 equals 0. So you have x equals 0 and x equals a third. That will have two solutions. If I divided by x here, I would have got rid of one of the solutions and have missed it out. So that's why we should not divide by sine x. Rather, we should do what we just did there. Rather, we should bring everything on one side and take out the common factor. Okay, so I can write this as 5 sine x times cosine x minus 4 sine x equals 0. Now I see there's a common factor of sine x. So I can write this as sine x times 5 cosine x minus 4 equals 0. Now I can say either sine x equals 0, or I can say 5 times cosine x minus 4 equals 0, in which case cosine x equals 4 over 5. Now, sine x equals 0. Inverse sine of 0 gives me 0 degrees, 180 degrees, 360 degrees. Okay, you know that the sine curve basically goes, as we mentioned, like this. And we also talked about in the last question, the calculator will give us a particular answer. If I press inverse sine of 0, it's going to give me 0. The other angle for sine is 180 minus the calculator answer. 180 minus 0 is 180. And then these repeat every 360 degrees. They repeat every 360 degrees, so you can see, that's going to be 360 plus 0, 180 plus 360, but we have to stop here only at 360. Now, you've got to be very careful here, because a lot of students will lose marks because of this. Here it says x is greater than 0, and here it says x is equal to 0. This angle is not going to be in our solution, because it says our solution should be for when x is greater than 0. So I'm going to reject this solution. I'm going to include these two. These two solutions will be included. So x, including the 360, because it says equal to 360, yes. So you're going to have x equals 180 and 360. Those are two solutions from this. Now we've also got solutions from this one here. So we're going to say x equals inverse cosine of 4/5. Now the calculator always gives us what's called the principal solution, the one that's closest to 0 you could think of for now. Right, so I'm going to take the calculator, which is over here. I'm going to press inverse cosine of 4/5. Now we are in degree mode, as we should be, and we can write the answer to degree of accuracy. So we have 36.869. I'll write it as 36.869 degrees. Okay, that is the main calculator answer, which is within our range. Now the cosine curve has a different shape from the sine curve. The cosine curve looks something like this. Okay, looks something like this. It goes through 0 at 90, negative between 90 and 180, and positive again between 270 and 360. And then it repeats the same pattern, just like the sine curve. So we've just found an angle over here, 36.869 0.86, whatever it was. Now, there's another angle on this side which shares the same cosine ratio of this. And remember, that's 2 pi up to there. So that distance is the same as that distance. So the other angle is given by 360 minus this 36.869. Okay, so I'm going to take the answer here. First of all, I'll store it as A in case we need it again. And then I'm going to do 360 minus the answer, which gives us 323.130. So we can say 323.130. That is the other main angle, which is in our range. Okay, now are there any other angles? Well, from these two angles, we can generate all the others. Again, the sine curve repeats the same pattern every 360 degrees. If I add 360 to both of these, I'll be outside of my range. If I subtract 360 from both of them, I'll be outside of my range. So these are the answers. X equals 36. And they want it to how many decimal places? To 1 decimal place. So 36.9 degrees, and X is equal to 323.1 degrees. Okay, so those are the solutions from this section, and these are the solutions from that selection. So there we have the answer to the question number 13, part 2. Okay, so we discussed for the cosine curve, we have first of all the calculator answer. So let me just write a summary for all three of them, just for those people who are having a bit of a problem. For the sine curve, we first use a calculator. As we do for the cosine curve, we first use a calculator. As we do for the tan curve, we use the calculator. That's the first step. All right, the second step for the sine curve is 180 degrees minus the calculator answer. And for the cosine curve, the second step is basically 360 degrees minus the calculator answer. 360 minus the calculator answer because of the symmetry of the cosine curve. And for the tan curve, the next step and all the other steps are just basically, it repeats every 180 degrees. So there's only one main answer, and everything else just repeats every 180 degrees. So for this, you do calculator plus or minus 180 degrees. All right, so you add 180 to your answer, you take away 180 from your answer, you keep doing that until you're out of the range. So the tan is pretty simple with these two steps. Okay, but for the sine and cosine, the third step is to take these two angles, angle 1 and angle 2, and add and subtract 362 and from them. Okay, add and subtract 362 and from both these angles until you have exhausted your range. And for the cosine, the same, because these two repeat every 360 degrees. This one repeats every 180 degrees. So the cosine, the same thing. You do basically your first angle plus or minus 360, and you have your second angle again plus or minus 360 degrees. So there's the answer, or there's just a bit of a summary for how to deal with sine, cosine, and tan. All of it is based upon the graphs. All of this stuff is based upon the graphs and the quadrants. So it's perfectly fine whichever way you use. So now the answers for this question therefore are 36.9, 180, 32.1 degrees, and 360 degrees. Those are the solutions to this question, number 13, part 2. Thank you for watching. Other questions from this particular paper can be found on the playlist, which will be in this area over here. Other questions from the topic of trigonometry, equations, and identities can be found in the playlist over in this area. You can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.